All right, let's get started. First, I'll introduce myself. My name is Peter-De-Santis. I'm our VP of Computing Services in AWS. I have been with Amazon 16 years and been with AWS for about 8 of those. Currently manage really our whole portfolio of compute-focused services, so that's everything from EC2 at the core, but also our networking services like Elastic Load Balancing and VPC, our big data services, our monitoring services, some of the new things you've seen like workspaces. So I'm very passionate about the compute side of things. But today, in this session, what I want to do is focus on our core compute offering and what we're doing to sort of push that forward. And so I'll briefly cover a brief history of EC2 to kind of give some perspective, and then cover some of the how we're thinking about compute going forward, specifically with relation to some of the things you guys have seen over the last several months, as well as announced here earlier in the day or yesterday. But first and foremost, I want to thank you guys for coming. As always, it's invigorating to interact with customers, exhausting over the last couple days, but invigorating at the same time. And I really appreciate you choosing this session. I know I'm competing with Werner and a few other really interesting talks as well. So appreciate you coming, and specifically appreciate you guys being here at reInvent and sharing your experiences and your requests. It means a lot to us. It really does inform our roadmap, and it will continue to do so as we move forward. Lots of great feedback so far, and I expect we'll hear lots more as the conference goes on. So I said it would be a brief history. 7 years ago, I think it was September 26th, we launched EC2 as a limited public beta. This is Jeff Barr's blog post announcing it. Having led the team that originally launched EC2, I vividly remember Jeff Barr's picture of his vacation, which you might imagine, as many of you have launched things, that we were all absolutely exhausted. And so this was a great reminder of that relaxation existed. So I was a little bitter with Jeff, but I thought it was a very nice blog post, and it was definitely an exciting time for us. So when we launched EC2 7 years ago, it was a pretty bare bones service. It's pretty incredible for me to go back and think about what functionality we had at launch, and that functionality was actually disruptively meaningful to customers. So, we had a single instance type, the M1 small. It had, much like Henry Ford's first Model T, you could have any color you want as long as it was black. It had 1.7 gigs of RAM, one CPU. It still exists today, in as much as we can reproduce it. I'll talk a little bit about that later on in the presentation, but this was our original one-size-fits-all instance type, and we were Linux only, so, again, any color you want as long as it's black. On-demand pricing only. We didn't have management console. We had API access only. There was no EBS. There was no elastic IPs. There was no load balancing. There was no VPC. There was no auto-scaling. It was pretty much run instance. Fortunately, we thought ahead and put the instance type in the APIs, but beyond that, it was really bare bones simple. What was exciting is immediately the value proposition of EC2 resonated with customers. And so even in the private beta, we saw a lot of very positive feedback, a lot of interesting usage. And really, it was that early customer feedback that helped us prioritize the last 7 years of roadmap. And it's been a constant cycle of launch, release, listen to customers, learn, build, launch, release, listen to customers, learn. Obviously, we try to get that, as you've seen earlier in the conference, we try to get that flywheel moving faster and faster over time. So since then, we obviously have a large number of instance types. I won't read them all. We've got many ways to pay for the service: reserved instances, spot instances. Within each of those families, there's many options. We support Windows and other OSs. We have auto-scaling, VPC. I could spend an hour on this slide alone. There's a large number of features. And again, if you had asked me which of those features people needed 7 years ago, I think we would have speculated on some, but really the totality of where we are today has everything to do with the use cases and the customers and the things that, the feedback we've received. And so now I want to kind of step back for a second, and in addition to all this feedback, we've sort of got a mental model for what we're trying to do with compute and all of our services, but specifically around our compute offering. And so this is trying to capture a few of the ways we're thinking about EC2 and the whole compute family, which I'll cover a little bit of going forward here. So the first thing, one of the first things we thought EC2 to be useful for, and the reason why we started with a simple offering with API access was we really, internally at Amazon, had learned that teams needed to interact with their infrastructure in real time, and that there was a lot of heartache around, a lot of complexity around picking up the phone, calling your infrastructure guy, getting another box, provisioning the box, getting the right OS on it, waiting for it to pass the provisioning process, installing your software, testing. And so one of the first things we started with EC2 was let's make sure that we have API access to all the things that we can do. So really it became automate my infrastructure. And so that is a sort of a fundamental premise. And to this day, we continue to iterate on reducing the complexity of interacting with it. So that's always having APIs, but it's also a lot of the investments we're making in our console access as well as the tools and interacting with the ecosystem of tools providers who are obviously doing a lot to innovate on how you interact with these very simple primitives. Second thing is scale. One of our earliest sort of prominent customer stories had to do with a company called Animoto, still around, still doing great things. And they immediately found value in dealing with the sort of, I think at the time we probably called it the Slashdot effect, the Twitter effect, the social media effect, but basically the fact that today you can start a company with a great idea and for some period of time get absolutely no traction, and then for whatever reason, some article is written, some popular celebrity does something totally unexpected, or you just have a great go-to-market strategy that happened to work, you get this surge of demand. And it's impossible to predict that surge of demand. It can be crippling financially for small companies to have to allocate the resources up front to deal with that surge. But if they're not prepared to deal with the surge, obviously they lose an opportunity that may never happen again. So this was a value proposition that's super important, and day in and day out, we spend a large amount of our time internally focused on capacity management, predicting customers, and doing everything we can to provide the illusion of infinite capacity to our customers. So this is a value proposition that we think is core to the service, and it's informed in all of our product decisions. Third thing is to give customers the tools to run in a highly available, resilient way. And so the core primitive that we offer for this is what we call availability zones. And so this concept of being able to run your application across very, very, very redundant, physically separated availability zones that have very high quality, low bandwidth, or low latency connectivity between them it was a disruptive idea that Amazon itself stumbled upon many years ago, and one that we thought was very important to offer to our customers and has become a cornerstone of application availability within the EC2 compute environment. We also, of course, have multiple regions across the world, and we do everything we can to keep our regions isolated so that there's no coupling. You'll notice from some perspectives, we even make it more difficult to use two different regions because we don't have our tools don't magically propagate data across regions in the same way that they do across availability zones. And this is an intentional design decision to maintain the isolation of regions to give customers full control, full isolation, both for availability reasons, but also for potentially for data control reasons, if you want to keep assured that all of your data is within a region. And so that's a little visibility into how we think about that. But in addition to that, we obviously have introduced a whole bunch of services that make it easier for customers to write highly available, resilient applications. One of the best that I'll talk about briefly is elastic load balancing. Another tenet is, and really is probably our first priority day in and day out, is security. And so this is obviously plays into how we build our services, but it also plays into the roadmap and the features that we provide to our customers to allow them to securely build applications for the cloud. And so our model has always been, actually one of the features that shipped in the initial offering was our idea of a security group, which was this dynamic firewall that allows you to sort of dynamically scale your capacity but maintain firewall consistency across your environment. And so in a cloud environment, a traditional firewall is almost untenable. You'd end up opening up way too much to the world, or you would end up with connectivity problems as you added capacity. And so the idea of a security group was our initial attempt at helping customers deal with this complexity and giving them the tools that they needed to be secure. Since then, we've introduced considerably more functional, complex, rich networking and security primitives, and two that I'll highlight today. One is VPC, which we've introduced many years ago, but we've spent a lot of time in the last year working on making it generally accessible to every EC2 user. So even if you don't want to think about sort of a traditional network and a big eggshell and subnets and routing, you can still benefit from VPC, and I'll talk a little bit about that in a minute. But also fine-grained permissions and really providing resource-level permissions in a compute environment is a big release this year that I'll talk about as well. And then the second to last point is about flexibility. So one of the core tenets with EC2 and our compute environment is we want to support a broad array of applications. And so we've really gone to great lengths adding operating systems, adding instance types, adding features and functionality to allow people to bring all sorts of applications. So we want big data applications to run well. We want transactional workloads to run well. We want Windows to work well. We want Linux to work well. We want really to unbridle our customers and our users to choose the tool that makes the most sense. And this is actually something that internally is a priority for us as well. We don't have really hardened rules inside of Amazon about which technology you must use to solve which problem. Rather, we empower our engineers to choose the right tool for the problem. And this has allowed us to move quickly, and we believe it's imperative, and therefore is sort of front and foremost when we think about our environment. The last one is reducing cost. This is everything from turning OpEx to CapEx, but also managing cost. And so, our original talk was a lot about the on-demand nature, but it turns out that customers have different requirements in terms of cash flow, commitment, lack of commitment, certainty around their business. And so we've really spent a lot of time introducing a number of, and I'll highlight some of them over the course of this presentation, ways for folks to pay for and consume compute capacity. So it turns out that I've covered most of these, so I'm going to move pretty quickly. I talked a little bit about, we started with APIs, but a lot of our focus has been ease of use. And so while we will always support our functionalities, all functionality we launch with APIs, we've also invested considerable resources in the last couple of years, and particularly the last year, in terms of providing a high-quality management console experience and also integrating with third parties so that they can raise the level of abstraction on top of our services. Scale, we talked about, resiliency, running across multiple regions. I stated that we don't replicate data automatically, but we have introduced a number of APIs and tools to allow customers to more easily run across regions. The one I'll highlight here is that we have a snapshot and an AMI copy functionality now that will allow you to explicitly copy your AMIs from one region to another. So if you want to run your application multi-region, it's a little bit more easy to manage that AMI and data infrastructure. We will continue to iterate and release functionality to make this easier and easier while maintaining that strong tenet of separation between regions that I mentioned earlier. Running securely, we talked a little bit about VPC, our virtual private cloud, as well as resource-based permissions. I'll touch on both of those. Flexibility, again, as you'll see, as you've seen, and as I'll cover a little bit more here, one of our big ways of enabling many different types of applications is providing multiple types of instances, everything from our high storage instance, which has terabytes of storage, local storage, and many spinning spindles, 24 spindles, very high throughput, to our IOPS offering, our I2, which Werner talked about this morning, and I'll go into a little bit more detail about, to our high compute offerings, which are very good for compute-intensive applications. But it turns out one size doesn't fit all. We kind of knew that at the beginning, but we've come a long way to provide a broad array of computing capabilities. And then finally, lowering cost. I mentioned the obvious benefit of paying for what you use, turning CapEx into OpEx, but also reserved instances and Spot provide very powerful tools for managing your spend and matching your spend to sort of your business needs. And I'll talk a little bit about those in a minute as well. So another part of our compute platform is Amazon CloudWatch, which is our monitoring platform. CloudWatch is used in many different ways. So first and foremost, it collects and allows you to monitor and alarm on operational metrics. And so many of our services, EC2, RDS, ELB, provide metrics for customers automatically. You can view these things just by going to the CloudWatch dashboard. You can set alarms on them. You can analyze them. You can also put in your own custom metrics. So if you want to put your monitoring data into CloudWatch, you can also use it for storage, alarming, and visualization of your data. So I'll highlight a couple of changes recently. So one of the things we've been focused a lot on with CloudWatch is getting more data into CloudWatch from our services, but also making it easier and easier to use the data that's in there, so helping it visualize and access that data. We've made a number of significant changes over the last couple months to make it easier to search, query, and access that data more quickly. And so I encourage you, if you haven't looked at the CloudWatch console in a while, to go in there and play around, and hopefully you'll be excited by what you see. Load balancing. So our Elastic Load Balancing service provides the kind of what it states, an Elastic Load Balancer. It's obviously a very important tool in terms of writing applications, request-based applications. Makes it easy to be highly available, makes it easy to scale, and does a lot of things like detect failing instances or failing availability zones and helps you route traffic correctly. Two pretty big changes that have happened with Elastic Load Balancing over the last couple months. The first one is we've integrated with Route 53, our DNS service, with something called health checks. This allows us to very quickly react to application level or infrastructure level failures in your backend host. And so this is going to increase your reliability. It means fewer requests get sent to degraded instances or degraded application servers. And then the second one is one that you're going to want to check out if you're running a multi-AZ application. Traditionally, our load balancer has segregated traffic to AZs, and this has resulted in sometimes a number of different problems. It means you have to have the same amount of capacity in each availability zone. It means that if you have a slow server or a slow set of servers in one availability zone, some of your customers might be seeing slow traffic while others might be seeing fast traffic. If you turn on cross-zone availability, cross-zone load balancing, ELB will automatically route traffic across your availability zones to the best possible instance, and this will result in latency and availability improvements. And so one of the big things about this is that there's no cross-zone availability cost for that. We route that in the most efficient way to your best available application server. So if you're running ELB, this is one I highly suggest you check out. And then Amazon VPC is our virtual private cloud. Basically, VPC was originally built to provide the abstractions that customers who are connecting from a private data center into the cloud needed. So it allowed them to put a firewall around all our instances. It allowed them to assign a particular set of IP addresses to those instances, and it provided very fine-grained, familiar networking abstractions to the user. But it also turns out that it provides increased functionality for users who are trying to do the basic things that we're doing in EC2 in terms of just having a simple network with security groups. And so what we've done over the last year is we've changed our product in a way that's largely unnoticed by customers so that customers are in fact running in an EC2 VPC without even knowing it. And so as of, I think, April or May this year, the vast majority of new accounts created in AWS were created in this mode that we call VPC for Everyone. VPC for Everyone essentially creates a VPC and configures the VPC to look as though you're running in a classic EC2 environment. So it basically opens up the edge firewall completely. It assigns public IP addresses by default to all your instances. It basically relies on your security group set up to manage connections between instances. But what happens, so when you first approach EC2 or AWS, you don't see any difference from the experience you would have seen on EC2, the classic EC2 experience a year ago. But what changes is, first of all, the underlying technology in terms of how we're routing packets, which is allowing us to be more efficient, and I'll talk about that a little later. But secondarily, it allows you to wake up and decide that you want to take advantage of VPC at any time. And so you can turn on that firewall, you can decide to change your subnet addressing, you can connect a VPN to your environment without having to migrate all your instances. So for our existing customers, we'll be providing guidance as well as tools to help you if you want to migrate into one of these new accounts, and we think you'll want to. And for new customers, they no longer have to worry about, am I a VPC customer or do I want to be a classic customer? So we think this is a super big improvement for our platform. Another security change over the last year is what we call resource level or fine-grained permissions. And so we had always allowed you to provide user-level permissions on API access. So John can run instances, but Joe cannot run instances. But these were very coarse. In June, I believe, we launched fine-grained permissions on EC2. And so what fine-grained permissions let you do is set resource-level permissions. So you can say that Matt can terminate this instance, but Joe cannot. And so that's a much more fine-grained permission scheme. You can use specific resources IDs like an instance ID, or you can tag the resources. For example, you could tag all of your resources in your production environment with the tag environment equals prod, and all of your resources in your test environment as environment equals test. And then you can say, Matt can change test, but he cannot change prod. But Joe can change prod. And so those sorts of very sort of broad but fine-grained permissions allows you to do some pretty powerful things, we think. One of my little announcements today, I wanted to give you something, is that one of the big requests from customers has been this idea of combining tags and permissions is really powerful, but because I can't tag my resources at creation, i.e. I can't put the tag on the instance at runtime, there's this window of time where the permission doesn't apply. And so in the coming weeks, you'll see us release the ability to tag your resources in your run API. And so this will allow you to put the tag on at instance creation time, and then whatever permissions you've defined on that tag will apply immediately. You can also combine these permissions with all of our IAM functionality, two-factor authentication, roles. There's a number of different things that I won't have time to get into detail. So I want to talk a little bit about our new instance types. You guys may have seen some announcements today, so I'll kind of give you a little bit more detail on my perspective on those, as well as we'll have a pretty interesting customer presentation. So as I talked about at the beginning, instance types do a few things. First of all, as we've launched many families over the last couple of years, we've increased sort of the applicability of EC2 for many different types of applications. HS1, HI1 have really addressed workloads that previously didn't have a good solution in our environment. At this point, we have a pretty broad array of instances, and for the most part, what you're going to see is that we're going to be very aggressively refreshing those instance types to give you access to the latest technology, whether it's the latest processors, the latest SSDs, the latest GPUs. And so you'll see generations of these instances come out fairly frequently, not daily, but on a very frequent basis that basically allow you to get access to some of the most recent innovations in hardware. What's the benefit of that? Well, obviously it allows you to get access to these things, but why do you want that? It drives up your absolute performance many times, but it also drives down your price performance, or up your price performance price. More efficient. So in the last 18 months, we've launched quite a few different types, and as I said, we've really been trying to broaden the addressability of our instance types. The HI1 was our first high IOPS instance, and it provided 120,000 random reads and somewhere fewer than that on writes. The M3 instance was our second generation of our general purpose instance family, which provided newer processors as well as faster memory and better IOPS performance. HS1, 48 terabytes of storage, very good for big data workloads like Hadoop, EMR. The CR1 instance is a big memory instance. It has a 244 gigs of memory and is obviously good for memory-intensive applications. And then we introduced a couple instance features. The one I'll mention here is the EBS-optimized instance. So with some of our older families, we of course, with EBS, released a feature this last year, early, called provisioned IOPS. Provisioned IOPS allows you to pre-provision IOPS inside of EC2 and then get very consistent performance. And then the feedback we got from customers immediately was, that's great, but sometimes my network, I saturate my own network and reduce my, this introduces variability. I'll talk a little bit about variability later. It's a super important topic. But one of our first things to reduce variability was allow you to set this EBS optimized flag. And what this does is it allows us to allocate additional network just for your EBS volume, thereby reducing variability. And you can really achieve very, 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 very tight tolerances with your IOPS on provisioned IOPS. So last week, before reInvent, we announced the G2 instance. The G2 instance is a super exciting instance. We previously had an instance called the CG1, which had a GPU in it, which was very applicable for general purpose workloads wanting to take advantage of the disruptive benefits of GPUs. The G2 is actually the first instance that we've introduced that allows you to have access to graphics processing capabilities. And so you may have noticed that in concert with our other announcements yesterday of AppStream and workspaces, we are very excited about the potential of taking visual applications into the cloud and getting that visual data to the customers. And much as I have said, we are a very flexible, flexibility is prime, and so you can see we've taken many different approaches to enable this. Everything from our new service AppStream, which allows developers to easily stream applications to end users, to raw GPU power in this G2 instance. And so I want to introduce our friends from Calgary Scientific here for a brief demo of a very, very cool application taking advantage of the G2 instance. Yep, thank you.
Calgary Scientific. This is Dr. Cameron Kittle. He's going to be my Vanna White today. I think her job's still safe, but we're going to need somebody to show you a few things. I don't have any PowerPoint slides. I figure you've seen enough this week. So we're just going to walk around a web page and do a few live demos for you to show you what we can now do on AWS. And as Peter just mentioned, you can do it for the first time as of last week. So we were really happy to be part of the private beta. It was pretty tough being under gag order for the last few months, but now we're allowed to shout about these things. So I'm going to try and shout right now. As far as Calgary Scientific goes, we are a company. We've got a few spots around the world, but we're mostly based in a place called Calgary, Canada, as the name implies. Enough about us. More importantly, what we do. It's called PureWeb Software Development Kit, and it will enable you to take any application, including some heavy lifting ones, which includes things like OpenGL, and be able to run them on the web, and now, as of last week, on the cloud. You can then access these things from any mobile device, and you keep all the data securely on the server. Now that sounds a lot like something called AppStream that was announced yesterday, and I want to reinforce that those benefits are all very important. The one difference between what PureWeb does and what AppStream does actually goes back to earlier in the keynote when they talked about the different strategies for migrating to the cloud. So there was one called All-In, always using Netflix as the example. And for all-in strategies, I think AppStream's a really good approach. I think we're also a good approach, and we'd like to talk to you about that. May the best product win, because there's going to be different times and different needs for each one. For the customers on the screen, though, they are going to want other options as well. So we're going to keep bragging about the benefits of AWS to them. We're going to try and drag them, some of them kicking and screaming, into the cloud. But they're always going to need some different options, and I'll explain a few as we go here. So we'll start by talking about medical. So why are we doing medical imaging on the cloud to begin with? Calgary Scientific is about 7 years old, so about the same age as AWS. And we started off by making a standalone medical imaging viewer. we noticed there was a pretty big problem. So these things are very complex applications, accessing very big data, and that data is just getting bigger and bigger. The scanners that are coming out for MRI and CT and other modalities are getting more complex and producing more slices, and they're getting cheaper. So there's an explosion going on of medical imaging data. We didn't try and address that problem head on. In fact, we were doing this before cloud was really big, if you will. So about 4 years ago, we approached it by trying to improve access. And so as far as the people who use medical images, radiologists and some of the specialties like neurorads, these guys are pretty rare. They're very expensive, and they do a pretty hard job. Today, they're still mostly going to where the data is. And 4 years ago, they had to. And this is usually into dark reading rooms, into hospital basements, where they had these complex workstations and applications reading these things as fast as they can. So we set out to improve access and get that over the web. And just to tell you a quick story about some of the benefits, because we've been out there for a while with this. This is FDA cleared software, and it's the only one that's actually FDA cleared for web, iOS, and Android devices. So people have been using this now for quite a while. It's available through a lot of companies that aren't us. A lot of household names who make the scanners and the medical imaging applications also sell us. So there's about a dozen of them out there. A lot of them have apps in the App Store. A lot of them are on their own brand name. In fact, all of them are, so you wouldn't have heard of us. But it's being used, and one of our lead users is the Mayo Clinic. And they do things like help us with those studies that get FDA clearance because the FDA didn't really know what to do with things like these iPhones and reading them on Android tablets. So we had our work cut out for us getting up there, and Mayo helped us. One study in particular, though, was about stroke. So we've heard stories now where radiologists have done reads without getting out of bed. That may sound like they're lazy, but really getting out of bed in the middle of the night to drive to a reading room because somebody had a stroke and just got scanned was a pretty common scenario. So Mayo Clinic did a study comparing using our software with the other approaches they already had and found a savings of 11 minutes using our software. 11 minutes may not sound like much, but in the case of stroke and other acute care, it's a big deal. In stroke, the expression is time equals brain. The faster you can diagnose, it's a big improvement to the outcomes of that patient. It means the difference between them being able to walk and talk or not. So that 11 minutes is a really big deal. So let's show you live, and we're going to show this on the hotel or the show wireless here. I'm not going to be like Steve Jobs and ask you to turn off all your phones. What we'll do is try and be more interesting so you're not shopping on Amazon.com right now. So Cameron has fired that up. He can search all these different modalities. We can go to different archives and load a patient. So he's picking Heather Hargraves, which is a good one because it's pretty big. It's a few hundred slices. And what you'll see here is us fired up, and the bottom right loading, that's important to watch. So Cameron's interacting with it right now in 2D, but it's loading all of the slices into the server as we speak. It is not downloading them over this hotel wireless. So Cameron is interacting with medical imaging in diagnostic quality live on the Amazon cloud. This is the first public demonstration of AWS medical imaging viewing, period, because before last week, it was not possible. The other thing Cameron's doing, he's actually not this kind of doctor, so he's going to call a friend. Looks like he's going to invite Dan Piggott. I hope he's available. And we have the ability, because it's run on the server, to bring in multiple people. Hold on, I got an email here. Excuse me while I check my messages. The other thing I've done is I've actually turned off the hotel wireless and gone back to using just good old phone networks here. We've been doing this for a few years and had to do this back in the day when 3G was considered fast. So let's see how I can do it here. We have the ability now, so Cameron, why don't you show us, say, clipping planes or maybe the lens tool, some of the more advanced functionality available, while this interweb thing gets me an email. So the other approaches we have, like this is a software application created by Calgary Scientific. We've now done a few different medical imaging applications and a few others which we'll show you. As far as the process goes, Cameron's going to keep interacting and doing a whole bunch of different fun stuff on there. and I'm just going to take an email message with a link and launch it. So you won't be able to see what I'm doing here, so let me describe it to you. It is actually launching up an iOS native app. Now, we have the ability to do this in HTML5 right within the browser, so the client is the browser on a lot of different devices. But in this case, we have apps and app stores. It's asking for my name. It's asking for an email address, because this is just showing authentication, and it's tracking who is doing what with this application. So I click Join, and it's going to take me into the application where I'll be able to watch what Cameron is doing here. So I can see on my phone. Let me go into everybody see that? It's pretty good, huh? Well, Cameron really doesn't know what he's doing here, so why don't I take control? And this is how you can see what I'm doing. I'm interacting with it on my iOS device. In fact, I can do a few different things. And this is called window level. OK, that might be too much information. All right. But I'm interacting with it in a native way. So for example, if I was to do pinch zoom, and I can also do window level with a double press, I'm doing these native iOS gestures. I have little scroll wheels and things like that, where Cameron has a completely different user interface. You can also see that Cameron has a panel there allowing me to interact or not. And so in other words, we can provide different levels of access by the different device. So the customization of the user interface is important, but also control over who can do what is important. So Cameron is now taking back control on a different device there. So we're now hogging this wireless, just us alone up here. So that, like I said, is the first demonstration publicly of medical imaging viewing done from AWS. To us, it's a very big deal, and we're really happy about these new G2 instances. But let's go back to the main page here, because this is a problem that isn't just confined to medical imaging. A lot of the other applications up here require GPU support and OpenGL even. Some of them don't. So let me touch on the one on the far right next, because that's actually old hat for us. It's called Ngrain. It's a simulation. We won't even show it. It's so easy for us. It's a simulation and training application that was CPU bound. The quick story about it is we were doing a prototype with this company a couple of years ago, and our developer, Matt, was in his hotel room with bad internet connection, so he decided to tether to his phone and uploaded their application to the Amazon cloud that night. Now, the day before, we actually asked the customer, like, what's your strategy for cloud? And they said, we've heard of it. And the day after, we went in and said, what cloud means to you is you can now run your software anywhere. And so it's a different conversation we were able to have, and there's a lot of convincing of customers about what this thing is all about. Now we can have that same conversation with a few different industries. I'll go over to the lower left here, CyberSKA. The SKA project, Square Kilometer Array, is a multi-year, multi-billion euro project which is placing radio telescopes in the deserts of Australia and southern Africa, in some very radio quiet areas. They have file sizes in the terabyte size, and it's pretty challenging stuff. And now, instead of moving those around, they used to collaborate around the world, but they'd say, download this and talk to me tomorrow. And they still wouldn't be able to see each other in sync. Now they can synchronize on iPads or whatever, work around the world instantly on the same instance. In the middle, we have a few examples of simulation and seismic interpretation, reservoir simulation in energy space. Now, this is a space that is also quite challenging. So Cameron's going to launch up Hugh Space here. Hugh was a company we met about 3 weeks ago. They're a very interesting Norwegian startup. They are really pushing the limits of what you can do with a GPU. This data set here is about 30 to 50 gigs in size. I don't even know. Cameron's interacting with it. There's a whole bunch of things you can do, but we've only had this application in our hands a few days. So he's actually adding another 30 gigs, 50 gigs, different data sets. He's visualizing here, I believe this is the northwest coast of Australia, all being done in real time and now being done on AWS. So this project took us about 3 days of the work you're seeing here, where the first day was actually trying to get the data from them because it was so massive. So we almost kicked it old school and mailed a hard drive. But we managed to get it up and running there, and we wanted to show it at the show here. It's working great, but I don't think this is the kind of application that we'd have Matt upload over his iPhone. It might get expensive, especially as we're roaming. So that's a couple of different examples. For completeness, I'll touch on the lower right corner, and that's just our conferencing functionality. You saw us connect on different devices. Around that application now, we're building functionality so that you can do video conferencing and other application sharing and even simple chat. So all the tools you might use in a conferencing application will now be available around the tools of these users, which will be running directly on the web. And I say web, now I can say and cloud. And we will be bringing some of these applications to AWS, and really thankful for the G2 capabilities because it's made a big difference in our world. So I'll turn it back over to Peter.
Well, awesome. Well, hopefully you guys found that as exciting as I do. I will say, one of the reactions that I've gotten over the last couple weeks as we've introduced some of these new workloads is a little bit of skepticism about the streaming of applications and aren't we going to a mobile device world? And I think we are going to a mobile world, but as you can see, I think there's a set of applications and functionality that's truly compelling, and we're excited about that, the intersection of cloud and streaming. So hopefully that'll give you some new ideas to think about. I'm probably going to move pretty quickly here because we're running out of time, but I do want to cover the two newly announced instance types. The first one is our new C3 instance. The C3 is the next generation of our compute-optimized family. There's been a few generations, the C1, the CC1, and the CC2. Going forward, we think you'll just see those as C3, C4, C5. The C3 is a super exciting offering for us. It obviously has this new Ivy Bridge processor, which is going to provide the utmost performance for compute-bound instances or applications. But it also, and it has a SSD for storage locally, nothing like the HI1 or the I2 that I'll talk about in a second, but it does have some local SSD storage. But what's truly exciting about it is the last point, which is the enhanced networking capabilities. So that it comes in 5 sizes, ranging from the C3 large up to the C3 XL, which has 32 virtual CPUs, 60 gigs of memory, about 640 SSDs, and goes for $240 an hour. So what can you do with this instance? Usually when we introduce our compute instances, we try to do a top 500 run, either internally or try to get it published. We don't do this with the goal of getting ourselves rated along with the sovereign-funded clusters at the top of the list, but rather to show the inherent performance of the instance type. And I'll highlight why we think this one is so exciting. The run that we submitted is at the top. We used 1,656 instances, which provided 26,496 cores and generated 484 teraflops on the LIMPAC benchmark. So that's actually would have put us around number 56 on the top 500 run of 6 months ago. What's truly exciting about it is the other 2 points on the slide. One is that it cost only $3,974 per hour, and it's competing with the top 100 supercomputers in the world, many of which are sovereign funded. What's even more exciting, before I go into what that 81% efficiency means, let me show you the result at the bottom, which is if you take out the June top 500 results, you'll see a whole bunch of different clusters in there, and part of those results show you what processor they're using. Many of the top 10 nowadays use GPUs. Top 100 are GPU-bound clusters, and they also use custom interconnects. And that's because the LIMPAC algorithm is one very efficient on a GPU, but it's also because it's very latency sensitive. And so that efficiency number is directly tied to the latency and variability of connectivity between the nodes in the cluster. And so if you look at that number 49 entry, which was the top Ethernet-based x86 cluster that was in the last top 500 result, it had 42,848 cores, which is 60% more cores than the run that I showed you above, and produced 13% more performance. And so the reason for that is because of the efficiency number. And so this was a 10 gig Ethernet-based instance cluster, which only achieved 51% efficiency, whereas the C3 cluster run above achieved 81% efficiency. And so you can do some quick back-of-the-envelope math and see that we would not have to add that many more instances to that cluster to surpass that number at the bottom. But again, our goal isn't absolute placement on these things. That would be a silly exercise in capital spending. It is rather to demonstrate to ourselves and our customers both the compute capacity as well as the networking capacity. But we are super, super excited about this, and I'll go a little bit more into how we achieve that network efficiency. But at the end of the day, it's a function of the reduced latency and decreased variability of the networking performance on that instance type. Another great point is you don't have to produce huge clusters to see these advantages. Here's an advantage of a cluster we ran with only 512 instances, which generated 163.9 teraflops and would have put you squarely in the top 100 on that list 6 months ago. Now, when the list publishes, things tend to move up, so I would expect that could move down. But the point being, you can produce a very substantial supercomputer for just around $1,200 an hour. The other instance you may have heard about this morning from Werner is our i2 instance. This is the successor to the HI1 and is our high IOPS offering. This one has two advantages over the HI1. One is in absolute terms, it's going to produce a lot more IOPS, particularly write IOPS. This instance has got about 350,000 read IOPS per second and about 320,000 random write IOPS per second, which is about 3x the number of reads that the largest HI1 could produce, and even more than that on writes. The original HI1 does not perform nearly as well on writes. It also provides more memory, and it has this enhanced networking capability, which I'll talk about in a second. Much like the C3, is going to have very low latency, low variability networking. But the other interesting thing is that this one is available in multiple instance sizes. The HI1 was not divided up nearly as well, so if you needed a slice of an HI, you couldn't get it. Here we have everything from the i2 large with two CPUs, 15 gigs of memory, 360 gigs of instance storage, all the way up to the i2 8XL with 32 cores, 244 gigs of memory, and 8 times 720 gig SSDs. The IOPS will, of course, scale proportionally to the size there. So I talked a little bit about enhanced networking. So enhanced networking is a new option that we're providing with our new instance types that you can take advantage of, which will give you drastically improved network latencies and variability. You have to do a couple things to take advantage of it. So the first thing you have to do is you have to be running in VPC. So remember I told you earlier that we want to get our customers on either VPC or a VPC by default account. Well, that networking stack allows us to make optimizations that are going to enable things like this going forward. So you have to be running in VPC. You have to be using an HVM-AMI, and you actually have to install or have had installed a set of particular network drivers that will allow you to take advantage of this performance. But all that is going to be well documented for you, and we will gladly help you figure out how to do this. So what do you get out of it? So this is a packet per second comparison between, on the left, the previous best instance we had in the compute family, the CC2 8XL, the new C3 8XL running without this enhanced networking capability, and then the C3 8XL running with the enhanced networking capability. And so you can see we're able to generate somewhere between 4 and 5 times as many packets per second as those older instance types. That will, of course, vary based on the size of the packet and the application, which is why I did not put an axis on this, but you can expect significantly enhanced performance on any network-bound application that's packets per second limited. And so you can think of things like memcaches or databases that tend to have lots of small transactions. More interesting is the variability. So I actually did put an axis on this one. This graph is showing a test run of several instances within a placement group, basically doing ping pongs. And so those ping pongs, we have many samples per second, per minute, per hour, running on all these instances over many hours. And so what you're seeing there is what's the median time, the P99 time, the P99 time, and the worst packet. And so that bottom line, which is right around, let's say 88 microseconds, is the median packet exchange time over the course of that run. And you can see it's very stable over the course of time. The line above it is the 90th percentile packet. So if you took all the packets in the given time window and you drew a line 90% of the way up, if you took the 10% worst packets, the best of those packets would be that bottom line. But what's most interesting is the top line. That is the absolute worst packet round trip time in each of the samples. And so you can see there is some variability there, but that variability, except for that one spike, which we will look into, is right around 140 to 160 microseconds. So, and this is not limited to a particular one switch 4-node cluster. You can provision hundreds of nodes with this sort of networking interconnect. And so this is very, 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 very different than even what people traditionally get out of standard Ethernet networks, let alone in a cloud environment. So we are super excited about this, and we're really looking forward to getting customers on these instances and getting feedback. I'm going to briefly touch on a couple of other things. The other part of performance, of course, is cost. We have something called reserved instances that help customers make choices around cost. Reserved instances allow you to pay for some portion of your usage up front, and then in exchange get a lower usage rate. There's a couple different variants of these things. They come in 1-year terms as well as 3-year terms. They also come in what we call light, medium, and heavy utilization. Depending on how you expect to use the instance, those tools may provide different levels of upfront payment versus different level of either optional or required per hourly cost. So the absolute minimum price, if you're going to run an instance for 3 years, steady state, is going to come from a 3-year heavy utilization RI, where you've pretty much committed to pay that every hour for the next 3 years. And that's very comparable to buying a box and putting it in your own data center. On the other end of the extreme, a light RI for 1 year is going to require a small amount of upfront cost, will not lock you into any additional commitment beyond that, and will allow you to realize a lower per hour cost than the on-demand equivalent cost. And so if you have a spiky workload that might have between 15 and 40% utilization over that 1-year term, this will allow you to both reserve capacity and get a lower effective rate over that time period. And so this super powerful set of tools for managing your spend, but obviously requires some thought. So 2 things we've done. The first is customers have given us feedback that RIs are great, but they want more flexibility. Like, I kind of know what I want, but could you just make it easier for me to switch over time? We've started to introduce some new features to allow you to have flexibility there. So you can change the instance type or the availability zone now programmatically of your RI. So if capacity needs change or you need a guarantee in a different AZ or you need to rebalance your RIs, you can do that via the web console. The other thing that we're going to be introducing, this is my other tiny little pre-announce for you guys, is some usage reports that will help you get a better sense of where you're using instances, whether on demand or RIs. And so you can look for this in the coming weeks. Here's a couple examples of some of the analytics you'll see. This view kind of shows you hour to hour, day to day, how much am I spending, how much am I using on demand versus reserved versus spot. And so this will help you spot trends, dig in, drill, and figure out where you have the opportunity possibly to shift some of that usage from one type of consumption to another. Another very common question is, what is the utilization of my RIs, which is not this graph at all, but is that title, so I'm going to move on. Final point I want to make is that, we're definitely, as well as these big things, we want to continue to focus on the small things that make the platform easier to use. And so we've invested a lot over the last year in terms of improving the EC2 Management Console. We've introduced a new look and feel that we think is better. We've received a lot of feedback. We're going to continue to iterate there, but we've also introduced a number of ease of use features like integrating the AWS Marketplace, which provides a number of third-party AMIs directly into the Launch Wizard experience, but also a number of other console improvements, which I won't detail here. But what I am going to say, because I am short on time, is thank you for coming. And the reInvent is such an exciting time for us. So much work goes into all these things that you guys see, and we feel great about where we are versus last year and some of the ways we've been able to respond to your feedback. But we also know that we have so much more work to do, and your feedback helps inspire us and guide us in that. So I appreciate that. Those of you I had a chance to talk to so far, thank you. And my team, all that feedback is very valuable to us. We thank you for your time, your energy, and for coming. So hopefully that was somewhat useful, but thank you.